Lesson 7 is on logarithms, which is really a grade 12 advanced functions topic. I just thought we would introduce it because you will talk about logarithms quite a bit in grade 12 math. It is a simple concept in the fact that it's very much related to exponential functions. It's the reverse. So one thing that I'm going to mention is that if I asked you what the exponent is to give me 25, you would say, oh, that's 5 squared is 25. And if I asked you what the exponent is to give me 125, maybe you'd say, oh, that's 5 to the third because that is 125. So if I ask you what the exponent is to give you 400, sometimes we may not know. Sometimes it might be a decimal. And besides using trial and error, the best way to solve this is by using logarithms. So far, we don't have the tools to solve this. Part of the reason is that we would get a decimal. Still, these types of exponential equations are solved every day. In order to solve this type of exponential equation, we must use logarithms. So the logarithmic function is defined as the inverse of the exponential function. We've talked about inverse functions before, or the inverse of functions that we were looking at in Unit 2. The inverse of an exponential function is a logarithmic function. You can also graph these functions, although we're not going to get into that at all this year in grade 11. The inverse of the exponential function, so if the exponential function is y equals b to the x, maybe it's not a big surprise that the inverse would be x equals b to the y. We're flipping, basically, the position of the x and the y. The next step is to solve for y. But how do we do this? In an attempt to describe this function in terms of y, the log symbol was invented. And it really is just log, and you'll see that button on your calculator most likely. A scientific calculator has a log button or a logarithmic button. So we have y equals log of x base b, and that would equal y. So in this case, y is actually our exponent. That's what we're going to find in the end. So it's just kind of working backwards to find out what the exponent must be to give you a certain answer. The base of our function is going to be this little tiny sort of subscript number, and then the answer is actually the x. So we're going to sub values in a slightly different way, and I'm going to teach you how to use your calculator. So some calculators that are extra nice, you might see a log button and there's like a little space or a little square and then a bigger square. And you can actually type in any base and any value into that equation if you have that type of button on your calculator. My calculator only has a log button. So I only have a button that looks like this on just a standard scientific calculator. So you're kind of at a slight advantage. This makes your work just slightly faster. But we can do logarithmic work with either type of calculator. So just remember, exponential form, x equals b to the y. Logarithmic form, the y is the exponent, equals the log of x base b. So the base, whatever the base was of your exponent, the base is still the base, but the answer is actually the x. So for example, we could have something like 16 as our answer. 16 is 2 to the fourth. 2 times 2 times 2 times 2 is 16. If we're going to write that in so this is exponential form. In logarithmic form, our exponent is the answer. So that's what we would have been looking for, is the exponent. And then we would have log of 16 as the answer from up above, but the base was a 2. So the way we would read that is the log of 16 base 2 equals or is 4. If you had a base, 2 to the exponent what gives you 16? 2 to the fourth is 16. So it's just a slightly different way to write it. So example 1, these are in exponential form, and these are true statements. So 2 to the fifth is 32. But in logarithmic form, we would have the log of 32 base 2. So that means 2 to the what is 32, and the answer would be 5, because 2 times 2 times 2 times 2 times 2 is 32. So we would also say that is the log of 32 base 2. This one might be a little bit trickier. This is in logarithmic form. We would say the answer is 1 over 32. The base is 2. So what is the exponent? And the exponent is actually negative 5. So does that make sense? 2 to the negative 5th is 1 over 32. And that should make sense. The numbers should make sense the way that it's written out. If you have a base of 10, so my calculator, when I just have the log button on my calculator, it's always assuming that the base is 10. So when we have a base of 10, we often don't have to write it in. So I could say that that is the same thing as the log of x base 10. And my answer is going to be y, that is the exponent. But more often you would just see that written in this form, because we would just assume if we don't see a base in our equation that the base is 10. So example 2, to actually come up with some of these answers, some of you might have a button where you could just type in the 64 and the 2, because there's sort of a blank left for you to do that. So there's a little blank and a bigger blank, and you have that button. So you could fill in the 62 and the 2, and you would get an answer of 6. If you don't have the fancy calculator, on my calculator, the way that I would type this in, I would type log 64 divided by log 2. And that would give me 6. So that's if I only have a log button on my calculator, which is true for most, $15 scientific calculators. That's probably the button that you'll see. What that is saying is 2 to the 6th is 64. So the question was 2 to the what is 64? So, you might have known that 2 to the 6th is 64 and you didn't need a calculator. This question is asking you 10 to the what is, so 10 to the exponent what is 100. So 10 squared is 100. You might not always need a calculator. If I wanted to use a calculator on that one, I could type in log 100 divided by log 10. Or because the base is already 10, my calculator deals with bases of 10. I could have just typed in log 100, and it should also give you 2. So you could double check that on your own calculator. And hopefully that makes sense, because 10 to the exponent 2 is 100. So for convenience and simple numeric calculations, we generally use base 10, and calculators have a logarithmic function using this base. So that is the log key. That would have a base of 10. There are 3 important properties of logarithms that you should be aware of. One is that the log of b with base b is 1. That's because b to the exponent 1 is equal to b. The log of 1 base b equals 0, because b is the base to the exponent 0 is 1. And also the log of b to the x equals x log b. So this might be a weird one. If I have a logarithm in my equation, I am able to take the exponent and write it in the front. So I can have this exponent out in front of my log b, and it equals the exact same thing. And we'll see that with our next couple of examples. So the very front of the page was asking you, what would this exponent be? Because 5 to the what is 400. So one way to solve this is only one way, I might show you a different way. We could take the log of both sides. So log of 5 to the x equals the log of 400. Whatever you do to one side is okay as long as you do it to the other. That means I can actually move this x to the front, and I can write that as x log 5. That gives me a base of 10 and equals log 400. And then if I wanted to get x alone, I would just divide both sides by log 5. So I would write it like this instead. A lot of weird steps that are different. And I would be able to use my calculator, because I don't have a really fancy one. Log of 400 divided by log 5. I should get about 3.7227. What that means is 5 to the exponent 3.7227 is about 400, or very close. So it's no wonder that we didn't know how to do that without a calculator. Another way to write that out, and you might like this a little bit better, or it might make more sense, if I just go to write that in logarithmic form, that is the log of 400, base 5 equals x. So that's what we were practicing on the other page, writing in logarithmic form. So then if I would like to know what that is, x would actually just equal the log of 400 divided by the log of 5. And I should be able to get 3.7227 in that way as well. Just thinking about writing in logarithmic form and then actually finding the log of what we have there on the left. Log of 400 divided by log of 5. If you have a fancy calculator, you could probably type in the 400 and the 5 with that special button, and you would also get the same answer. So this last one, maybe we'll do this in two ways as well. So one way is to take the log of both sides. And then to move the exponent to the front of the left side. And then I would want to divide both sides by log 4. So I would like to have the log 4 on the right, and I'm going to divide. And then to isolate my x, I would also, since the 3 is multiplying, it could actually be written in the denominator and come down and multiply by 3 log 4. I don't know if you like those steps or not. And then I can actually type this into my calculator, log of 55 divided by 3 log 4, and I get about 0.9636. Maybe a different way, if you just want to think about writing in logarithmic form, so what I had originally is 4 to the 3x equals 55. So in logarithmic form, I know that 55 was my answer, my base was 4, and the answer in logarithmic form is my exponent. So that's one thing I could do. My calculator, I would have to type this in as log 55 over log 4, and that equals 3x. Maybe I'd find the answer for that. I got 2.8907. But then to get this x alone, I would have to divide both sides by 3. And I get 0.9636. So it's the same thing, but maybe written in a different way. I don't know, it's up to you. Both are sort of equivalent ways to solve your answer. So I'll leave, whichever method you think makes more sense, and you could give it a try.